Hello, Rose. For lesson 1.12 on answering quadratic word problems, I thought what I might do is go over 3 of the questions from our lesson, but answer different questions related to the same function. So in question number 1, we were given the population of a Canadian town, and I think P of T was the population. T was the number of years since 1992, maybe, or 1990. It's not going to matter for our question. We are going to be asked to prove that the population was never 20,000. There's a couple of interesting ways we can go about this problem. Approach number 1, I'm going to set up an equation and use the discriminant. And what I want to do is show my reader that if I set my population equal to 20,000, that the quadratic equation that's created will have no solution. So to do that, I need to communicate really clearly that I am setting my population to be 20,000. Discussed this a couple of times. The population is variable. This statement, P of T equals 20,000, is false. That's not always true. In fact, we're trying to prove that it can't be true. So it's very important to have these 3 little letters in that order right there. If we set our population to 20,000, then we get the quadratic equation 20,000 equals 12t squared plus 800t plus 40,000. And when looking at a quadratic equation, we generally try solving by setting one side equal to 0. I mean, we could try solving it by completing the square, but it's going to be a bit of a mess in this case. I'm going to subtract 20,000 from both sides. That'll get me 12t squared plus 800t plus 20,000 is equal to 0. And I could probably divide both sides by 2 or maybe even 4 or maybe even 12. It's hard to tell here. But the discriminant provides a great tool here, which when used with the calculator, it doesn't really matter how big these coefficients are. It should tell me if this equation has any solutions. So I'm going to announce that I'm using the discriminant by using the agreed upon capital D here. I might even show my substitution into the formula for the purposes of reviewing in this lesson. And I'm going to substitute in the coefficients 800 for B, minus 4 times 12 for A, and 20,000 for C there. Now it's calculator time. 800 squared minus 4 times 12 times 20,000 equals... Now I know, or I'm pretty sure given the wording of this question, I know what's supposed to happen here. But that means it's kind of more my job to sort of communicate what the issue is. So I'm not surprised to get a negative discriminant because I was supposed to prove that this could never happen. Just make sure that you're clear with your conclusion. Tell me, what is it about this discriminant that means that there's no solution? I'm going to say this number is less than 0, therefore the equation has no solution. And therefore the population was never or will never be, was never 20,000, like that. Okay, that was me using an equation and the discriminant. I guess the other way, and depending on how we had approached the question in previous parts, would be to think of it graphically and either complete the square or just use a shortcut to find the optimal value. I'm aware that this curve opens up. If I can show that it has a minimum, there's my population curve, that's greater than 20,000, that will mean that the population was never 20,000. So to find my optimal value, I think the fastest way of doing this is probably through the axis of symmetry shortcut. T is going to be negative b over 2a, which will be the opposite of 800 divided by 2 times 12. Let's see here. Let's do 800 divided by 24. That'll be, I don't think I should round it off. I'll call it negative 100 thirds. That means that my optimal value is going to be, oh, that was me announcing the strategy. P of negative 100 thirds, which I guess I'm going to use standard form here. It's a good idea to write down what I'm about to type into my calculator. Maybe not so much for communicating to your reader, but I've found that students that make calculator mistakes often were trying to type it in without seeing what's in front of them. Typing this into your calculator is going to be a lot easier now that you see it on your page. I'll do 12 times negative 100 thirds squared plus 800 times negative 100 thirds plus 40,000. And that's going to be about 266,666 people. I'll round it off to the nearest person. Maybe I should have rounded it up to the nearest person. Okay. The minimum population is about 26,667. So the population will never be 20,000. Two different approaches, both relatively efficient, I think, both well communicated. Question number 2 was, sorry, that's strategy 1, strategy 2. Question number 2 was, we were working on a function h of t equals negative 5t squared plus 20t plus 25, right? This was the worker throwing the tool through the air with a ridiculously, like way high up in the air and throwing it really high. My numbers might not have made sense in the context of the problem. This time, what we're going to do is, let's see if we can figure out for how long the tool, for how long, let's try, was the tool above 40 meters. And technically, what we're doing here is we're solving a quadratic inequality. And we'll get a little bit more practice with inequalities later, but I'll share with you the approach that we actually use in advanced functions and calculus, is that if we can solve an equation and then use what we know about the curve. So here's what I know about the curve h, because of our experience with the previous questions, with its initial height of 25 and its maximum height, can't remember what it was, 45 maybe. Yeah, if I can figure out when the tool was at a height of 40 meters, let's call that time 1, and this down here time 2. Then I can just say, oh, between that times is when it was above 40 meters. So once again, I'm going to use the word set because I'm not told that the height is 40 meters, and that's not what I'm trying to figure out. But I'm going to decide to solve an equation because I think it's going to help me here. So I set my height equal to 40 meters, and then I continue with my equation. And solving equations is a lot easier than solving inequalities. There's all sorts of issues we'll discover with solving inequalities that we just don't want to deal with if we don't have to. Let's divide everything both sides by 5 here, I suppose. It'll make our numbers a little bit smaller. I didn't bother doing that in the last example, but I think I see some better approaches here. That'll give me 8 equals. I wonder if I should have divided by a negative. Yeah, well, for t plus 5. Maybe not, because I'll just add t squared to both sides, subtract 4t from both sides, and subtract 5 from both sides. Now I'm trying to solve this quadratic equation to figure out when the tool was at that height. Easiest way of solving quadratics that I should always try, because it's way faster when it works, is solving by factoring. And hey, look at that, it works out nice. T equals 3 or t equals 1. So yeah, if I've figured out that the tool was at a height of 40 meters after 1 second, it passes 40 meters on the way up after 1 second, and then it passes 40 meters on the way down after 3 seconds, then I can figure out for how long it was above that height. I just need to communicate my step again here. I think I'm going to say the difference here is going to be 3 seconds minus 1 second equals 2 seconds. Okay, just tell me what you're calculating, show me the work as well, instead of jumping to your conclusion. And we'll say the tool was above 40 meters for 2 seconds. And we're done. Okay. Didn't have anything else for example 3 for the was a paddle boat or something like that, the cost. Question number 4, though, I have something else for us. Question number 4, we were given a profit function, P of n equals negative 0.5 n minus 8 all squared plus 8. It was the profit for a small video game company or video game parts company. The profit was in thousands of dollars. Thousands of dollars. But the number of parts was, I believe, in hundreds. And one short little question I want to answer here is, let's determine the company. I think it was Alex. I can't remember. Determine the company's startup costs. And this should have been something that we illustrated in class, that when we have a profit function, we generally, when we make 0 items or sell 0 items, we generally have a loss. It usually takes a while for us to produce enough items to actually start to break even, and then to start to earn a profit. I think we calculated break even points in the lesson, or maybe we tried to figure out how to maximize. No, we wouldn't have figured out the maximum because we would have just been reading that off of the graph. Yeah, so the company's startup costs, what I want to stress here, we are looking for the dependent variable, but we do not need to expand to standard form. That's the most common inefficient solution that I see in this type of problem. The company's startup costs are going to be its profit when it makes or sells 0 items. So I'm just going to substitute 0 into this function, and I communicate that with function notation. Okay, the startup costs are not visible in this format. It's not going to be $8,000. It's going to be the profit when I sell 100 items. And it's just a matter of calculation from here. I can do 0 minus 8 is -8. -8 squared is 64. 64 multiplied by -1/2 is -32. -32 plus 8 is -24. -32 plus 8 is -24. Yeah. Now, the other thing I want to discuss with this question is, of course, our profits are negative because that represents a loss or an initial cost, but I should not mention the negativity in my conclusion. Okay, this is a negative profit, which translates to a loss or a cost. So I will say the startup costs are, and I've translated the negative with the cost there. Then I'll mention that it is 24, and I can say 1,000. I could write it like this: $24,000. This is why it's very important to declare your variables here. To say that P is the profit, we don't know if it's measured in dollars or in rupees, if it's measured in hundreds of rupees or thousands of rupees or blue rupees or green rupees or red rupees or thousands of dollars. This doesn't mean $24. It means $24,000. Okay. Try it out.